This is the Art of Network Engineering podcast. In this podcast, we'll explore tools, technologies, and talented people. We aim to bring you information that will expand your skill sets and toolbox and share the stories of fellow network engineers.
Welcome to the Art of Network Engineering, where we try to be that intersection between the tech and the people. I just made that up, Andy. What do you think?
I like it.
Is that our new tagline?
It's good. Yeah, I can.
Don't tell AJ. He'll hate it. Anyway, I am Tim Bertino at Tim Bertino, and I'm very excited this week because we didn't record last week, so I haven't seen my buddy Andy in over a week. And you'll have to check out our YouTube channel because he's got a whole scruff lumberjack thing going on, and it's fantastic.
Thank you, Tim.
How are you, buddy?
I'm good, man. It's always good to see you. I wish we lived closer. You know what I mean? Nebraska's just too damn far from the outskirts
Everything?
of Philadelphia.
Yeah.
Yeah, I'm good, man. The house is decorated for the holidays. Work is great. Very fortunate to be where I'm at doing what I'm doing. I'm going to say it again.
You just hit a year, right?
Yeah. I have hit a year. I made it a year. I'll tell you, the first 6 months were tough. And Mike told me that. You know, we're all going to have to be a little uncomfortable for a while, right? Because I had never done that type of job.
Yeah.
So, what do I say? Like, fortune favors the bold. Or you got to take some chances. And I feel like every job I've taken in tech has been a leap and uncomfortable and, full of uncertainty. But I trust the leadership and I trust the process. And yeah, after about 6 months, I started to kind of groove in. And now a year in, I have a couple things that I own that feel really good to be working on. And yeah, man, can't complain. How's Tim's world?
Oh,
I mean, you look great. I love your new look.
Thank you. This doesn't just happen overnight, Andy. Takes a lot of work and perseverance. My wife hates it, by the way.
Does she? Aw, I can't wait till we get together again in real life. I'm going to rub your head. I might lick it.
No, things are good. It's getting to be the end of the year. It's a time where you want to be around your family and just kind of enjoy everything. So it's starting to slow down for the end of the year. Kids are all getting excited. It's Christmas every day. We gotta find the hidden elf every day. I still don't understand that, but that's the thing.
That's the worst thing. Yeah. Give parents more crap to do.
I feel like it's harder for me to find than the kids, but they must have like a sixth sense for that kind of thing.
I want to put out there in the universe for all you married guys, right? So I'm the guy for 10 years that have been letting my wife do everything because she's so good at it and probably not helping as much as I should with things like Christmas or birthdays. She'll buy all the presents and she claims to like it and she does it all. And then I come in at the end and wrap some stuff and I'm a big hero. And I have reasons and excuses why. But this year I decided, you know what? So we actually set a date. we had a date where we went out like shopping. I mean, which really was just us walking around Target and Kohl's like with shopping carts. It's the most unromantic date I've ever had. But she said this is the first Christmas since we've started a family that like she's not stressed out. She's not obsessing about, did I get enough? Or because I've been way more involved. So
that's awesome.
Support the moms out there, husbands. I'm trying to lead by example here. Yeah.
Well, you got a leg up on me, man. We have done tons of laps walking around Amazon.com.
Yeah.
But no, it's been good. Like I said, it's a fun time of year and just trying to enjoy it.
Has it snowed there yet? You're in like snow country, right?
It did today. Not a ton. But I did get a snowblower this season, so it'll probably never snow again. Which honestly is okay.
Right.
But hey, that's the way it goes.
I got one last year, man. We'll have to trade some snowblower stories. All right, who we got tonight, man? This poor person's been staring at us for 5 minutes, just talking the crap that we talk. We've received feedback like, why do you guys just have the host sitting there talking while you guys banter? But then we have other people say we like the banter, so you can't make anybody happy.
You can't win.
No, you can't win.
All right, so who we got?
But I am very excited to introduce Rowell Dionicio. Rowell is the host of the Clear to Send podcast, all about Wi-Fi. Rowell, how are you?
I'm doing wonderful. Thanks for having me.
We're really glad to have you because we kind of sat back as a group and thought, we're like, okay, we are 2.5 years into this as a group. We are over 100 plus episodes. We have yet to do, about network engineering. Wi-Fi is a big part of network engineering. We've yet to do an episode on Wi-Fi. And I think a big reason of that is between the group of us, none of us are really SMEs on Wi-Fi. A few of us have experience. We have it in our networks and we're responsible to it to an extent, but none of us are really hands-on in it every day. And I have listened to Clear to Send multiple times over the years, and you actually did, it was about this time last year, you ran a Twitter space where you just kind of invited a bunch of people on and we're talking Wi-Fi, things that are coming up in the industry. And you were really open. I think I jumped on for a minute and asked a question.
Yeah,
it was really
that.
cool. So, so I thought, hey, if we're going to talk wireless, we got to get Rowell on here. So if you don't mind, Rowell, can you kind of give us a background on yourself, where you got the interest or the itch in technology in general, and what, why wireless?
Yeah, I've always had a thing about tech. I started at my first role was help desk. So I've came from the help desk, become a sysadmin. I've done, I was IT manager for a short time, then went into network engineering. So I've done all of it, maybe touched a little bit of everything. And I like technology in general. I like tinkering with things. I like putting things together, trying to troubleshoot. But the one thing, I don't know what it is about Wi-Fi. I think I was working somewhere and no one knew how to do Wi-Fi. But where I was working at, one of our clients, the MSP I was working at, no one knew what to do, and it was such a critical thing to them, right? So that's when I just started to learn and pick up Wi-Fi in general. I learned pretty quickly I was doing it wrong. So I figured I'll be the one to help others on the team in regards to Wi-Fi and kind of take lead there.
So you turn the gain all the way up on everything, right? I mean, that's what I do.
Full power all day.
I was surprised when somebody told me that's bad, right? Like,
it can be bad. Yeah. I mean, it's not always bad. I think in our industry, a lot of Wi-Fi people will say, don't ever put it at max power. But I mean, you're gonna put it on max power sometimes. It happens, right? If you hopped onto my network and looked at RRM, you'll see some things on max power. But what it really comes down to are people able to work on that Wi-Fi network? Are they able to do what they need to do? Then it's done its job, right?
Yeah, I'm glad you brought that up about seeing a gap. We have a lot of listeners to this show that are either trying to break into technology, either they're younger in their career or they're making a shift. And I think that's a good piece of advice, is to show some initiative, that you're willing to pick up something that is either nobody else is really an expert in, or it's an underappreciated skill set. That's how you can get ahead. That's how you can show initiative. So I find that really interesting. That's how you got your start in wireless.
Yeah, it was just something I put myself out there, and like what you were saying earlier, Andy, about taking risks. Like you got to take those calculated risks, right? If no one, and it doesn't have to be Wi-Fi in general. If you see a technology or area that no one seems to be an SME in, maybe that's something you can take as an opportunity to become that person. I mean, granted, you should probably like it, but I've seen some opportunities and I'm like, no, I'm not doing that. And we talked about this earlier, Tim, like voice is one of those things I won't do or SharePoint. And so those are two specific technologies I've removed from my resume just so nobody can talk to me about those two
Don't
things.
tell anybody. I know.
Yeah,
right?
you're interviewing for a wireless engineer position, and you end up becoming the exchange person.
It doesn't mean it's not useful to know, right? I think one of the things that's helped me a lot is being in help desk and sysadmin roles. Because as a network engineer, when you're troubleshooting, it does help to know how the user or other engineer is trying to get connected or try to access resources, and makes it easier or faster for you to troubleshoot.
Yeah. Having that first person experience with the end user is just invaluable. I mean, I spent 5 years as a cable guy. Similar to help desk, right? Like everybody's calling me every day with stuff not working, and I'm out there like, all right, what are the symptoms? What's going on? What can we do? Like, you really get good at troubleshooting.
Yep.
So you were at a place that they had wireless and they needed help. Like, was there one person doing it and they needed help? Like, how did you fill that gap?
It was just a little, I mean, the team I was on, they all had to do wireless, but no one really knew how it worked, right? So if I go back to how I did Wi-Fi, and maybe a lot of you guys will relate, is you have this access point and it's very easy to set up, right? You turn it on, plug it in, have an SSID. If you can connect to it, great. If you can't connect to it, I need to add another one somewhere, right? As I walk further away from it.
Yeah.
That's generally how people start off. But once you get into more complicated environments, then it becomes a lot more trickier that way, right? Small office is relatively easy to deploy Wi-Fi for. A lot of times people will think they need to do a design for a very small office, and I'm like, well, one access point, 5 people, you're going to be fine. Guarantee you'll be okay. But it's about knowing what to look for when you're doing Wi-Fi. And so just like with network engineering, right? If I'm getting into networking, what do I need to know? It's the same thing with Wi-Fi. It's just a different medium, right? With networking and switches, routers, we're dealing with cables, wires, right? And protocols. It's the same thing with Wi-Fi. It's just there's no wires, there's radios, but there's also Wi-Fi protocols. So I had to shift my mindset from different protocols and different physical mediums to dealing with the Wi-Fi side.
So I want to tap into that, because I think that was one thing that even to this day has got me nervous about wireless is with traditional, what I call traditional wired route switch. Everything's there. Everything has those physical connections. And when you get into wireless, things get a little bit more nebulous. There's a lot of science and physics behind that. And my question for you is really becoming a wireless engineer, how much of the physics do you really need to understand to be able to build, maintain, and support wireless networks?
I think you'll get pretty far not knowing too much physics. If you just understand how light bulbs work, you could get ahead pretty far. If you've got a light bulb, you got one in the room, you go on the other side of the wall, how much of that light actually goes through the wall or through a curtain? That's kind of the same thing with Wi-Fi. You lose the intensity of that light when you put something in front of it, right? Or shape it differently with a lampshade. That's very similar to using something like an antenna to shape the signal to a specific area. So if you understand that kind of physics where Wi-Fi is much better and much more reliable, closer to the user, you'll get pretty far. But there is physics involved, and that's when things get, more complicated.
I like that light analogy. That's really cool.
I agree, Andy. I've actually never heard it
Yeah.
described as that before, as an analogy. That's interesting.
Same with your microphones. Your microphones are the same way. My mouth is pretty much right on top of this microphone, but if I move to the side, my voice gets a little bit weaker because the shape of that microphone is really just right here. That's the same thing with the antennas.
Well, I love the light analogy because we can see light, but with our voices and with Wi-Fi, it just seems magic. Like I can't see it, but it's there and my stuff is working. So here's my one silly talking about physics. As a cable guy, every time, and you'll probably know right away, Rowell, but so I get a call and I'm like the 10th guy there. Every time their phone rings, their Wi-Fi goes out.
Their phone, I don't know. They're using some old cordless phones then. Right.
Residential. So because we were taught some of this stuff, microwaves and old cordless phones can jam 2.4 gigahertz. And so, Tim, like, not that this is physics, but this is like some nerdy crap, right? So I get in there and like, hey, every time, and and every other tech that came in is like, this customer's crazy. They don't know what to talk. So I'm standing there next to their, customer owned router, Linksys, whatever the hell it was. And I call them from my thing. And as soon as the phone rings, all the lights, it just went out. Like it killed it. I was like, oh, well, you got to replace your router. Like, and they didn't believe me. And they called my boss the next day and like, he told me I need a new router. I'm like, listen, man, and I think I even looked it up and it was like on the same frequency, whatever. But yeah, but that's my one, I worked in very small environments, one access point. I'd centrally locate it wherever I was, the office or the house. That was usually sufficient. Some of the bigger houses, you'd plug in the awful range extenders, which I don't think anybody should do.
No.
Yeah, they're all terrible. So the one question I have for you, because I say this, Rowell, and I don't know if it's true, but I think it's true, is all wireless half duplex communication?
Yes. Wi-Fi is half duplex.
Which is why I hardwire everything.
I wouldn't say all wireless, right? Wireless will encompass a lot of different technologies, but Wi-Fi is half duplex.
Yeah. Half duplex isn't as good as full duplex, right?
It's not. And marketing does its magic on those boxes, right? You go to Best Buy, you see the latest, spider looking router thing, and it's like 9.6 gigabits per second. But what they don't tell you is it's an aggregate of the 5 gigahertz total max capability, the aggregate with the 2.4. And then that's, if you can get full duplex too, it's half duplex. So, cut that in half. And
I guess it doesn't matter because I can pull like 180 megabits a second, off my local, router.
That's all we really need,
I mean, it's fine, right? Like, but as a network engineer with wires, I know full duplex is better. And I'm like, wire everything when you can.
Full duplex is better. I'm a network engineer, and I will admit that my Wi-Fi is currently disabled. I'm hardwired for this one.
Same. I'm hardwired as much. Tim's probably on Wi-Fi, aren't you, Tim?
I'm usually wired, but yeah, tonight's different. I'm sorry, Andy. It's because of Rowell. I had to show off.
Wait, do you have a wire sitting there and you're not using it on purpose?
It's a long story. I don't want to talk about it.
Hey, it's all right. The wired guy is using Wi-Fi and the Wi-Fi guy is using wired.
So you really took to Wi-Fi, I guess. Oh, go ahead, Tim.
Yeah, I do want to. I want to get into some more in depth like wireless design, but what I wanted to talk about real quickly because I want to make sure we don't forget it for our audience. But Rowell, in your experience working in the wireless space, what are some of the different career opportunities or job roles that are out there? Is it really just wireless engineer and you're in charge of everything from design, implementation, and support, or are there different types of roles for people focusing on wireless that are out there?
Yeah, I think the most common is just a network engineer, and you'll have Wi-Fi as part of your wheelhouse. Then you have the dedicated Wi-Fi engineer, which will probably encompass everything from doing the design, the configuration, the troubleshooting, and also what we call validation surveys, where you go on site and use specialized software and hardware to gather data of the Wi-Fi network. So that's probably the most common one. And then sometimes larger organizations will split those roles where you have someone who just does the design, someone who just does the configuration and troubleshooting. And then you have some people who just do the validation survey, and that's a lot of walking around and using either a tablet or a computer to tap where you are.
So that was something that I wanted to spend a good deal of time on this podcast talking about. I think we hear, so a lot of end users, customers, people walk into buildings and the wireless is just there, right? You can tell who the IT people are when they walk into a retail space or something, because they're always looking straight up at the ceiling trying to find out what model of AP that the store's using. But usually when we see those things, they're already implemented, they're already done, they're already working. We hear this term that's called in the design phase, that's called a site survey. Can you kind of talk about what a site survey is, what the importance is, and why we need to do them?
Yeah, I think the term site survey just gets thrown around all over the place.
Sure.
And so I do have to ask questions on what exactly does somebody mean with a site survey? Like, do you need a design? Do you need I like calling it validation survey, because if it's already been deployed and you just need what they call like a heat map, you need a heat map. That's a validation survey. And then we create a report that shows you all these different requirements that you're meeting or not meeting, whatever those requirements are that the end user defines. But yeah, a site survey can also mean somebody going on site, and let's say it's nothing's been deployed yet. So there's something called like an AP on a stick. So basically you take a tripod, there's an access point on it, and you take it to proposed locations to kind of make the design a lot more accurate than just using what's called a predictive design. Predictive design, we're just using a software to place access points on the floor plan. It's all simulation, and it takes a lot of different parameters or characteristics of different access point models, and we try to be as accurate as possible. But I like to emphasize, I do tell people that is a predictive model. It's not going to be 100% accurate, and that's why we do the validation survey afterwards to see exactly what the coverage looks like. Are we meeting capacity? Do we have other settings that need to change?
In your experience, is the predictive survey done more often than somebody actually going out on site and doing that pre-survey?
No, I find that most people do not do predictive designs. It's one, you need pretty good, accurate software to do that. And a lot of times an organization is just going to do this once, so they're not going to invest in the application to do that. So they'll guess, or they'll let their salesperson guess how many access points they need. So I find that most people do the validation part where they say, hey, I think we have a coverage gap, but I'm not sure because I can't see the Wi-Fi. So I just need they need someone specialized to go do that for them and create a heat map.
So I think I already know the answer to this, but are all spaces created equally? And I'm talking interior spaces. Do we need to treat walls and cubicles or open offices different than like large auditoriums or theaters or that kind of thing?
Yeah, some interior office carpeted space tend to have similar characteristics, but a lot of times, yeah, they'll be very different because of the layout, the walls. A lot of times I might guess that it's a drywall, but it happens to be drywall on top of a brick wall, those kind of things. And so that changes the signal strength, or the attenuation. It attenuates a signal much more stronger there. So that's where we find those kinds of things in a validation survey. And I'm able to use that information to tell whoever the end user is, like what they need to do to make it better. Either adding a new access point or just maybe moving some, dropping them down from the ceiling where it's hidden. Typically it's like hidden access points. And I don't like that for a lot of different reasons, is because when you place an access point on a ceiling tile, or like this is the ceiling tile right here, right? And all the desks, and then they place the access point right on the top. The propagation pattern of that access point is typically like a down tilt omnidirectional. When you place it right on top,
it doesn't go like up into the
It is, but yeah, it's going up. There's nothing behind. There isn't much behind it, right? So if you got the plate on the back there, it doesn't really propagate as much behind there.
Gotcha.
So when people lay them on top of the ceiling tile, it's great signal for the HVAC, but not for the end users.
Yeah, that's interesting. So you talked about signal propagation, and I think we know that there's a bunch of different types of APs out there and a bunch of antenna types. So how do we know what type of AP to pick for and antenna for that matter for a specific area?
And then how many to put in, right? Because I'm thinking like a huge auditorium. I would have no idea. Like, is that a predictive software thing? Are you guys walking around with sticks in an auditorium? Like, how do you figure? Because it seems like black magic. Somebody said in the chat, like Wi-Fi is black magic.
Wi-Fi is black magic.
How would you figure
I can say the same thing about BGP. I don't do it that often.
Yeah.
It's black magic. It's like it's the pipes for the internet, right?
But how do you pick the AP and the antenna types and how many? Like, is it an art? Does it take a while to figure out?
So a lot of that depends on the requirements. And so I always ask people, right, tell me about this space, show it to me. You have a floor plan, because there's a lot of the things that go into it, like aesthetics, mounting capabilities. Like, can I place an access point there? Can we run cabling to the access point? If that's not possible, then alternative. But in the very, very beginning, we talk about, okay, how many devices are going to be here? I always start with people, because most of the time, whoever I'm talking to doesn't even know what kind of devices. So we'll take higher ed, for example, because I'm a network engineer at a university. We have a lot of lecture halls, and a lot of times there's no one I can talk to say, hey, what are the requirements you need for Wi-Fi in this lecture hall? I may get lucky and talk to a professor, and they tell me how exactly they interact with the students and what they do over Wi-Fi. But a lot of times I'll count the number of seats. I do that with office space too. I count the number of desks. So if I got an area with 30 people, I already know there's going to be minimum 30 devices, especially if this is a office or lecture hall. 30 devices are going to be used, right? And then everyone carries about 2 or 3 devices, so you can multiply that. But in the design software that we use, there is a lot of math involved with the physics. So there is a capacity to Wi-Fi, which is all due to the physics. It's like a pi, right? Think of a 5 gigahertz radio as a pi. If there's one device, they're going to have, everything of that radio. Just like when you walk into the kitchen in the office, there's one pie there on the table. I can eat all that pie if I wanted to. But, if 10 people showed up, I got to divvy up the pie, 10 slices, so I get a much smaller slice. So that's how Wi-Fi is in terms of capacity, is like, okay, how many devices are going to be here? And also what a lot of people don't think about is what kind of applications are going to be used. Because if you got 30 people and they say, all 30 people are going to do Zoom, that's going to be a problem, because with all the video that you're uploading and downloading, that's going to eat up the capacity. And then if most people are just doing email, that's typically fine. And so in the application that we use, there's different applications. They can do capacity planning, and you can put in the number of devices, what kind of applications you think they're going to use to determine if the number of access points you have is going to meet those requirements, the capacity requirement.
And that,
it's a lot more involved. But
so does that take into account? That then takes into account not just the capacity, but the coverage area as well. Because I think that's...
Yeah, with Wi-Fi nowadays, coverage is a given. It's just 100%, including the restrooms.
And that's what I wanted to highlight, because when I was really first starting out, coverage was what you worried about. You wanted to make sure that everybody had a good experience, and what I always thought of a good experience was we had to have coverage, and that I think has changed into, like Taylor was asking, how do we plan for capacity? Because that's a big part of this now, is, like you said, it's not just one device per person anymore. You need to plan for that. And that's how I was wondering, and I'm glad that you walked into that, of that software.
Design
that
is super critical.
Yeah.
Yeah. Design is going to be most important, because in the offices I've been in, almost everybody is Wi-Fi, and now people aren't adding as many Ethernet drops. So not everyone will be hardwired. And a lot of times not a lot, but there are a few times where I have recommended that certain people go Ethernet. I've been in an environment where everyone was over Wi-Fi, but this environment, it was like almost like a cubicle farm, but they were in like in a warehouse. So there's a lot of desks. No one moved. These were all desktops with a Wi-Fi adapter, but they were downloading high resolution photos, uploading high resolution photos, videos, all at the same time all day. And Wi-Fi just couldn't meet the capacity because everyone was so close to each other that even if I added more access points to try to meet that capacity, the physics of RF, because it propagates very far in an open space, we ran into capacity RF issues, physics issues with co-channel interference, things like that. And so I in that scenario, I recommended that they hardwire their computers, and they told me that they wanted me to make it work over Wi-Fi, and I showed them the design. I'm like, look, this doesn't meet. We're not going to meet your capacity requirements. Even if I picked 30, if I just said 30 of these devices will upload high-res images and videos, it still doesn't meet the requirements.
Wi-Fi just couldn't meet all the bandwidth requirements, right?
Yeah, it was just an RF physics capacity issue there. And eventually I just stopped working with them because they didn't want to believe me. And when one of the engineers left, I spoke to him saying, hey, what'd you guys end up doing there? And they're like, oh, we ran Ethernet cables.
You're getting me excited with co-channel interference. I really want to get into the nerdery. Can we get into the nerdery yet, Tim?
Go for it.
Let's go.
Damn. So I remember from 2.4 gigahertz, you have those 3 channels you can use that don't interfere with each other, right? Is it 1, 6, and 11?
In the US, yeah.
Oh, fancy. So does that mean if you put one access point here and then you need another one, I don't know, X amount of feet away, this one should be on channel 1, the next should be on 6? Like, do you stagger them like that so that they don't fight with each other? Yeah,
and it's not. Wi-Fi is pretty nice as a technology. It doesn't really fight. It just backs off. So the way Wi-Fi works is because it's half duplex. It will listen on the RF on the medium before it even transmits. That's with APs and devices. And so it listens and goes, do I detect a signal? If I do, I'm just going to wait. And
collision detection. That was like the old switching we used to do, the CSMDA, whatever the hell it was. Remember? Yeah,
but it's avoidance in Wi-Fi. Because on Ethernet, you can detect signal and be able to recover. But in Wi-Fi, it is possible for multiple devices to transmit at the same time. And then that signal gets all jarbled up because it's in the same frequency. Right?
So with 5 gigahertz, is there co-channel interference? Like, or let me back up. What's the difference between 2.4 and 5? Like, what's the big? Why is 5 so much better and faster?
So 2.4 gigahertz is a lower frequency, and it propagates farther. It doesn't attenuate as much through materials like drywall, but there are not as many channels that we could use in 2.4. And like you said, there's only 3 non-overlapping channels. I mean, you can put APs on the same channel. What happens is, actually, I'll table that. In 5 gigahertz, there's a lot more channels, right? So,
because it's a higher frequency, is it like a physics thing?
No, it's not that. It's because the I'll just say the FCC allowed a certain amount of frequency that we could use in 5 gigahertz for Wi-Fi. And so with 2.4, with 3 non-overlapping channels and 5 gigahertz, in the same amount of configuration, like a 20 megahertz wide channel, we get about 24, 25 channels that we can use that are non-overlapping. So you have more capacity that way.
Oh, and 5
now
gigahertz.
There's channel in 5 gigahertz. Now there's channel bonding and all that, and that gives you higher throughput. Yeah. But think about co-channel, like having a meeting in the office, right? How many of you have had 2 different meetings in the same room?
Doesn't happen.
No one, right? No one does that. Yeah, you would never understand what the heck's going on in that meeting. So having two meetings in the same meeting room is like having two APs on the same channel, operating on the same channel.
Okay.
And if they can hear each other, if they're in close proximity, you would, like in a meeting, when two people talk at the same time, you have to wait. Only one person can talk in order to understand what that person is transmitting or saying, so you can receive it and comprehend it. It's the same way in Wi-Fi. We try to avoid or minimize co-channel. It's not always negative, right? If you've got an empty office and all the APs are on the same channel and a few people are there, it's not going to be a big deal. It becomes a challenge when there's a lot more devices on the network, a lot more APs operating on the same channel, they're all in the same close vicinity area, then they share the same capacity of that channel. And that's why co-channel can be bad.
The 5 gigs is faster. There's less interference. There's more channels, but it doesn't go as far. Can't have
it attenuates more. But in 5 gigahertz, you could do channel bonding. So you can take two channels, combine them into one channel, but then you minimize how many non-overlapping channels that you have.
What we call magic. And is 6 gig here yet?
It's here. I have about 3 APs I am testing with 6 gigahertz. I have 3 6 gigahertz clients, but that's about it. So it's here. Are we using it? No, not yet. So
it's better than 5 gig. How more bandwidth, more channels.
There's a lot more frequency there, so a lot more channels. I don't even have those numbers memorized. That's how many channels we have.
Okay,
so where in 5 gigahertz. Yeah, in 5 gigahertz, we recommend 20 megahertz wide channels, maybe even 40 megahertz wide. With 6 gigahertz, they're saying that's going to be, you'll start off at 80 megahertz wide channels. That's how many channels are available.
And then we may see much faster, right?
Yeah, we should see more potential with Wi-Fi, like see those actual capability of Wi-Fi.
Does it still have the attenuation issue that 5 gig does as opposed to 2.4?
In my initial testing, I'm seeing that the signal is actually lower in 6 gigahertz. It's a higher frequency. Yeah. Okay. So the higher frequency you go, it gets attenuated more.
Last nerd question I have, and then I'll give it back to you, Tim. So I have a relatively big house I'm trying to cover. I have one centrally located guy in the kitchen, and he seems to do a pretty good job. Security. I'm not asking you to design my network. I'm going somewhere with this. so I have
doing some live troubleshooting.
Yeah. So I have a security camera, wireless security camera on the other side of the house, and it wasn't getting a good signal. It was choppy. So anyway, I ran an Ethernet out to there, and ran an outlet and put an access point. Autonomous. I don't have any controls or anything. So that's working fine. But the coverage in my yard is bad. So I'm eventually going to have to figure out a better solution, because we got a pull out back. So now you might want to get on your phone out there, and the wireless is crappy. So where I'm going with all this is I got into mesh systems. I started looking into the mesh stuff. Yeah. But what I was reading, and you know better than I would, do they all use are they backhauling?
Yeah, they'll use a radio as a backhaul.
Right? And that's not good, right? There's a
No, it's because it's still half duplex, so it's you're not getting much. I mean, you're pretty much just getting coverage is what you need, right? But hey, if you need to do it at home, it's no problem. I try to make sure all the APs have at least Ethernet, but I know it's not always the case, right? So mesh is convenient for us when you need to get Wi-Fi in an area, but you don't have the infrastructure cabling to bring it there. So you use Wi-Fi as your backhaul, which we call mesh, where an access point will connect to another access point and will also at the same time simultaneously serve clients, maybe on another radio. Sometimes we do see APs that mesh where the radio that's a backhaul will also serve clients as well. And that's also much worse, because instead of being a dedicated backhaul mesh connection, it has to do multiple things, right? So it has to go, all right, let me help you. Okay, now I need to go send your data back to the root AP. So, I mean, you sacrifice throughput, bandwidth, but you get coverage.
Right. and which is why I haven't done it, because I'm obsessed with bandwidth for some reason. So I wouldn't go mesh. So like a person like me who needs multiple access points in their environment, I mean, do I need a controller? Do I need to buy into some system? And because right now they're both autonomous, they're on different SSIDs. Somebody on Twitter is yelling at me saying, well, just put them on the same and it'll roam seamlessly. But I think I tried that and I had problems, or it didn't work.
Yeah, it's not going to roam seamless because they are autonomous. They don't know of each other.
Right.
So it won't roam seamlessly.
And then the iPhones seem to stick to the first one they're on, even if it's a lower signal, right? I mean, is that a known thing with them?
Yeah, Apple devices are known to be sticky.
Yeah.
Apple does have good documentation on how their devices look for new access points. But because you're running an autonomous system, it looks like 3 separate Wi-Fi systems, but they just have the same SSID.
So if I put both of those autonomous APs on the same SSID, that doesn't solve the problem, right?
No, I mean, you maintain the same SSID so it can rejoin to another access point, but it's just not a seamless handoff.
So how do I get a seamless handoff? Do I need a controller, like an enterprise?
You would need you can do a controller, or you can go get one of those cloud managed APs nowadays. Like even Eero does a great job. I run Eero at home for my family, and then in my lab I use the enterprise gear. But yeah, you can use Eero. There's the Google Mesh stuff. If you hardwire a lot of those, the roaming is pretty good. It's more seamless than having autonomous APs.
So seamless roaming means I don't have to drop it. Like, so with my sticky Apple devices, if I have seamless roaming, will they be less sticky? Will it not be still holding on to the right? Like it's still okay. I'm in the yard.
More of a coverage.
Yeah. Okay.
That's more of a coverage thing. So devices, we haven't talked about this, but devices are what decide what they want to do on the Wi-Fi network. We just kind of help. We can try to help influence them or manipulate what values look like to them. But ultimately, a device decides whether it wants to roam or not. So Apple devices, because I work a lot of Wi-Fi networks with Apple devices, they tend to look for access point, a new access point, somewhere around -72, something like that. And so if your signal is still -72, you'll be good. It'll stay on that access point. So it's really about the thresholds of the device. Those devices, like even a non-Apple device, some of those aren't documented. So it's really the magic sauce of whoever made the phone, the OS.
Yeah, I do think that's something that definitely adds a wrinkle into both the design and troubleshooting, is that because a lot of that decision making is left up to the clients. Like you said, Rowell, we can try to influence things with certain protocols on the wireless side, but it's ultimately up to the device. So you can have, Andy, like you were saying, that issue with sticky clients where you can have fantastic coverage. A client can have a poor signal. It can see an AP at a much better signal strength, signal quality, but the client doesn't move. And that's not the infrastructure's fault. That's just the software, the driver, or the type of client that it is. And that definitely can add some confusion and frustration into day-to-day operations. I don't know how you do it every day, Rowell. That shit drives me nuts.
Now, there is such a thing as too much coverage, where I've been in many environments where I've seen access points like every 10 feet. And so when I do a validation survey, I can show them what coverage looks like for each access point. So I'll show them, like, look, you have one access point in the middle. You have another access point 10 feet away from it. If I just show you the signal of that one access point, it actually covers the whole floor. But obviously you want to plan it for capacity, which is why they add more access points, right? But I was trying to explain to them that if one person went from one desk, took their laptop and went to the other side to their colleague's desk, they wouldn't even roam to another access point because the signal strength is still very, very strong on the opposite end. So they had deployed, I don't know, maybe, if I remember correctly, like 4 or 5 for an area where maybe 2 or 3 would be sufficient even for the capacity. But it just becomes one of those things where you need to know the devices that are going to be on your network. Now, I know there are some areas where, like universities, schools, you don't know what those devices are, but if you can understand maybe generally what kind of device is going to be there, you can design to the worst capable device. So like if you look at warehouses, for example, you have laptops, but then what is the most crappiest device on that network? It's going to be those handheld scanners. So you need to design the Wi-Fi network to maybe those handheld scanners, or even IoT devices if they're going to be on moving structures. So
kind of that you need to design to that least common denominator kind of thing.
Yeah. So if you can design to, and that's why these requirements always come up, is knowing what exactly is going to be used, right? What is the mission critical device that's going to be used on that network? So for hospitals, like maybe it's these little ASCOM devices that doctors and nurses wear around their necks. Like you need to know how that works on the Wi-Fi network. What is its minimum signal strength that it needs? How does that look like when someone's walking? It's in front of them, right? And if you think about us, we are just bags of water walking around. So we attenuate.
I've been called much worse, Rowell.
It's funny because I never tell that to clients. Like try to tell them how
you're a bag of water, dude.
You're just a bag of water. Get out of my face.
If you guys weren't such big fat bags of water, we'd have better signal in this office.
I actually ran into that situation not too long ago where this guy was the access point was behind him. Then he sat at his desk and the laptop was in front of him, and he's like, "Yeah, my Wi-Fi signal is just not that great." And I'm like, "What if we just move to the side? You know, the laptop can see that AP." And then I was just trying to explain to him that, you know, if you put something in front of the device, it's gonna get a weaker signal.
Sir, you're a big bag of water. You need to lose some of that water.
So, Rowell, we've talked
even with
about,
requirements.
We kind of talk about the different device types and how there's a lot of uniqueness in our networks. And it seems I've come across over the years where you'll get vendors of these different device types, and sometimes they'll want their own SSIDs. We're special. We need to be separate from everybody else. We need our own SSID. But you go back to vendor documentation and best practices on the infrastructure side, and you know, the vendor documentation's like, you really want to limit the amount of SSIDs that you're throwing out there. Is that due to performance, and we want to reduce the amount of or increase the amount of airtime that each individual SSID has, and the clients have more time to talk? What's the reasoning behind that?
Yeah, for every SSID that gets broadcasted, there's something called a beacon. And that's how you're able to see that SSID on your device. And so an access point will broadcast a beacon for every single SSID. If you've got 10 SSIDs, that's 10 individual beacons that get broadcasted out, and that takes up airtime. So airtime is our most precious resource here. And if there's a lot of devices and a lot of SSIDs being broadcasted, you'll have this issue where management frames, which are just the overhead communications of saying, here's a Wi-Fi network, tend to occupy most of the airtime. So there have been some really Andrew Vonage has been a really great resource for people, especially in my Wi-Fi career. He built this SSID overhead calculator that goes into the math and tells you, if you've got this many SSIDs, here's how much airtime that eats up. And so that's why we want to limit the number of SSIDs.
So Taylor has a good question. Does hiding the SSID improve airtime because it limits the beacon?
No, because you still have to know about the SSID, right? If it's hidden, how do you know that you can connect to it?
I should be asking you that question. How do it know, Rowell?
So hidden SSIDs still get broadcasted. It's a frame that just doesn't show anything. the SSID doesn't show.
Oh, so it's
if I do a
SSID.
Yeah, if I do a sniff on Wi-Fi and it's hidden, I see it. I just don't know the SSID name. But the moment your device that's configured for that SSID, once it connects to that SSID, I can then see the SSID name. Because the device will say, "Hey, I want to connect to this hidden SSID."
So
so that's how it gets exposed.
I mentioned, like, it's so interesting to me, the different terms that you're throwing around and like how it. So we talked about coverage. You said capacity earlier. That one office put in a bunch of access points to increase their capacity. I'm surprised to hear. I mean, is capacity a big issue you run into a lot? Like how, because then I go to like a sports stadium, you got like 70,000 people sitting in a stadium.
Yeah.
How the hell would you handle that capacity without having one every 10 feet? So can we talk about capacity for a second? I mean, I would think our hardware has gotten to the point where one access point can handle a hell of a lot of bandwidth. Is bandwidth and capacity the same thing, or am I not even in the right ballpark?
Yeah, you've
here?
got, so even I get confused on these terms, right? So the way I think about capacity is how many devices can sufficiently do what they need to do over on that access point, over the air, given the application that they're trying to use. So I always go back to, all right, you've got 30 devices, they all need to do Zoom. Like if you just do the math of like 5 megs requirement per device, and there's these calculators that you could use online that determine how many. I go back to Andrew Van Osh because he created an Excel sheet that helped calculate how many access points you need to sufficiently cover the types of applications are being used per number of devices. Going to the stadium example, those are much tougher environments. So usually it's not the best performing Wi-Fi networks, but you have this, what I call a take rate. Not everyone is going to be using Wi-Fi simultaneously at a stadium, right? You're there to watch an event. You may get more people just trying to record something and upload that to social media.
You got to publish those selfies, Rowell. I was here.
Yeah, exactly. Yeah, you got to have proof, right? And that's usually what the stadiums are going for. But now they're adding things like ordering from your seat, order concessions. And so that becomes more of a challenge. And so that's why 6 gigahertz is much more, people want to get used to 6 gigahertz. And now there's other wireless technologies as well that could help with that. Because we haven't even talked about some things like private 5G that has other use cases. Ultraband has other use cases. Those are all operate on different frequencies, have different use cases. But Wi-Fi is generally the most widely used one.
The capacity is just the hardware's ability to handle. It sounds like bandwidth to me because you
physics,
said you said 30.
It's mostly physics,
right? Just how much stuff you can jam into those air signals at the same time.
There is a capacity for access points. So you'll see things like channel utilization. That channel, how much is actually being used up by whatever's being transmitted over the air. But then I find too that access points have their limits. Some access points do well with more clients on them, some do not. So there's no equality of vendor there. I'll hear vendors say, "Hey, we all use the same chipsets," but it also comes down to their developers and how well their chipsets interact with. I don't know that stuff.
Software, baby.
I just knew. The software, they have their own set of APIs using with the chipsets. So software is part of it. Quality of the hardware, quality of the radio that's on the access point matters as well.
So I do want to pivot a little bit. We've been talking a lot about these post-deployment validation surveys. And you, as a wireless engineer, you have to know the tech behind it. You have to know wireless. You have to know the physics to an extent. But you then also have to turn over a report to a customer at some point. So I think you know where I'm going with this. You have to have a skill set too to be able to explain your findings to people like myself who don't know what the hell you're talking about and don't understand those things. So how have you done that in your career? How do you take that, all of that data, all of that detail that you've gathered in your surveys and present that to somebody who doesn't really understand it?
Yeah, so this is where in our careers where the soft skills really matter, right? I can talk technical all day, but you may not understand what I'm referring to if I start putting out 3-letter acronyms and DBM values. You don't know what that means to you at the end of the day. So it comes down to still knowing what their requirements are. Like why do they need Wi-Fi? What are they trying to achieve over it? But they have it deployed and they're not able to meet those business objectives. So I try to map the results of a survey to certain business objectives as well as technical objectives. A lot of times I see misconfigurations. So that's the majority of the things I see. So when I'm talking to technical people, they tend to understand what I'm referring to. When I say, hey, here are the different settings I recommend to optimize this so you can get better performance over your current deployment. And a lot of times it's referring to numbers, right? Maybe they got a quote to replace the vendor. I get this sometimes where they say, we're just going to rip and replace vendor A for vendor B. And I'm pretty sure that'll be much better. Okay. I mean, if my car wasn't working, would I just go buy another one just because, or would I try to figure out what's wrong first? So there's different ways to handle it based on who you're talking to. And I think the soft skills are such a critical point where you want to be able to relate to the end user, be able to address their main concerns rather than straight up talking technical jargon, confusing them. You may sound smart, but you're just confusing them even more. And they're just wondering why they paid you to come out and you don't know what you're supposed to do after this.
Yeah, I think that's tough. And something that a lot of us struggle with is as we try to become better versed in our craft, we learn those things. We learn the acronyms, we learn the tech behind it, and we get those so ingrained into our heads that I think it's nature for us to just go to that when we're trying to explain stuff to other people. And yeah, it's very important to be able to know your audience, because at the end of the day, you're there to provide value. And if you're just saying things that mean the world to you, but nothing to somebody else, your customer, then it does nobody any good. And like you said, they're wondering why they paid you to come out and do that.
Yeah. I mean, knowing the technical stuff, don't get me wrong, knowing it really helps. It'll help you even further if you can translate that to something people can understand. And so I always tell people to at least get their CWNA, which is the foundational Wi-Fi non-vendor. It's a vendor neutral certification. It's the Certified Wireless Network Administrator. That'll get you so much knowledge and foundations into Wi-Fi that that alone will give you what you need to get started and become better. And then knowing and talking to other people, being able to translate that jargon will even, it just makes it easier for you because you actually bring more value. And then for your end user, or even just, your coworkers, maybe you're talking to some VP, he just wants the breakdown, right? And this is what I learned over time is when you talk with higher ups, they don't care about the technical stuff. They just want to know the bullet points of what needs to be done and have you done it already. And so if you can break down, the troubleshooting and the validation survey into 3 bullet points, 5, you're golden.
Doesn't that sound great? I can't wait to be a VP and not have to deal with the technical crap anymore. just give me the 5 bullet points, Tim, and stop giving me all this damn.
I've learned that with my reports. I've sent some out to, because a lot of times I deal with the IT managers or network engineers, and when I do deal with VPs, the first thing they always say is, "I just need the summary of what needs to be done." Like they don't even care for the results, and so I've always now just in the beginning of my reports have an executive summary that says, "This is what you need to do. This is what happened. This is what I found. This is the issue. Here's how you fix it."
I have a CWNA question. I actually thought that was a Cisco certification because of the C. So that I'm happy to hear that's a vendor neutral one. Would you recommend that Do you need a baseline of networking knowledge before you go into that? Like, should you ever CCNA first, or can you just go in blind and will it teach you network fundamentals as well? Like, right? Because
No,
you need network
you can
fundamentals
dive
to know
into it.
wireless, right? Or maybe not. Like, I don't know.
Not necessarily. The CWNA is by a group called CWNP, Certified Wireless Network Professionals, and that certification covers just Wi-Fi generally. So you don't need to know things like subnetting and stuff you don't need. You have calculators for anyways, right?
Right.
Same thing. I have my own calculators in Wi-Fi as well. And so it'll give you that knowledge, right? The different frequencies that are being used. What are the different radio frequency characteristics? How does antenna selection matter? What are the different types of antennas? All that will help. Even if you're a salesperson, be a better salesperson, because then you can sell the right wireless equipment. I've come across lots of salespeople who just generally throw a lot of equipment in there, but I've gone into those scenarios where the customer just wants to rip and replace it because they just think it doesn't work, but really they just didn't go in with a plan. So they didn't do a design. They didn't configure it properly. They didn't make sure it was installed properly afterwards. And so where the networking actually comes into play is troubleshooting, because most of the issues, you guys know what most of those issues are, right?
Internet's slow.
DNS, DHCP, routing. I'm just kidding.
Is that the biggest complaint you get? Is like my wireless is slow?
Yeah. Wi-Fi is slow. That's a tough one to crack. My Wi-Fi drops.
Oh yeah, that's a big one.
And then when I really dig into it, it's never dropped. Actually, they just think it drops.
So I want to ask this, Tim, before we wrap. I know we're getting close. So, you talked about you were a help desk guy, and I don't know if you went to network and then wireless, but you were in a role, like a technical role, networking adjacent, and got into wireless. So for somebody listening who like loves wireless, has a passion for it, thinks it's amazing, that would like to get in, maybe they're not a network engineer or a help desk person who can fill a gap like you had said. Is there a recommendation you would make? Like, is it, get your CWNA and do these 2 or 3 other things and then try to get a gig? Like, what's the path? Yeah, if you had to say.
Yeah. So I think it's always a common question, right? Even for people who are trying to get into network engineering in general. I'm a little biased because I came from help desk and I understand the types of tickets that come through. And I've seen tickets just get thrown around like hot potato because people think they always point fingers, right? It's always a firewall issue or a routing issue. What kind of change did you make? For me, if you really like Wi-Fi and want to get into it, you can get into it right away because we all have Wi-Fi at home, right? The Wi-Fi at home is not that much different from enterprise. You just have different equipment. You have a consumer equipment, whereas enterprise has enterprise equipment, but it's the same frequencies, same protocols that are being used. So you can pick up that CWNA book and be able to go through it and start using your own Wi-Fi network as a lab. So that's easy to get into. You don't need to purchase enterprise equipment. The only time you need enterprise equipment are for enterprise features. So things like RRM, see in a consumer device. I won't be able to toggle that on my Eero. It just does it for me automatically. Now, when it comes to being very, very useful in your job, and I'm talking general jobs, like you walk into an organization and you're going to wear many hats, right? This is where having done help desk really helps. One, because it gets you closer to the user and you understand how the user does their work. You know what kind of things they're doing to make problems, because they do cause problems. 2, you work on your communication skills because now you got to talk to end users. And so you got to learn how to talk to them in a way where you're not demeaning them or being disrespectful. You can communicate things properly to them. Things like troubleshooting over email, this is the hardest one. Telling a user what to click on specifically, that's hard, right? So being very descriptive, like when a user says, well, I'm on a Mac, how do I do that? Well, I know how to do it because I use a Mac, so I can be very descriptive. But when was the last time I used Windows? Like I still know generally how to get there. Or even dealing with server guys. Like I've had to help server guys where they say, hey, my server's not talking to another server. I think it's a network issue. And so you just have to know fundamentals of networking to kind of drill in and troubleshoot, right? It's the same thing with Wi-Fi. But knowing help desk kind of gets you actually in the mindset of knowing, all right, if a user has a Wi-Fi issue, what kind of questions can I ask them to try to get to a root cause without, wasting a lot of time? And then getting into networking with I always tell people CCNA just because it covers such a wide area of networking. They get into subnetting, which is important. I've seen a lot of weird subnets out there, different clients' designs, like network designs that are kind of questionable. And then troubleshooting Wi-Fi, where networking comes in handy, is when someone says there's a Wi-Fi issue and you've ruled out Wi-Fi being a problem. And I mean, radio frequency not being a problem, the configuration of Wi-Fi not being a problem. How do you then tell someone where to go next? If I say Wi-Fi is not the problem, but the user is still sitting there going, well, I am not working over Wi-Fi, it sounds like a Wi-Fi problem to me, then you're kind of useless, right? And so knowing how to troubleshoot a little bit further and understanding, okay, do they have an IP address? What subnet are they on? Can they reach the gateway? Can they reach another subnet? Can they reach the internet? Like those kind of things. That's where networking does play a big role. Like, what's the difference between pinging an IP address and pinging a host name? Does that mean DNS works or not? Like, I've run into different scenarios that way where they kick up an issue to me saying it's a Wi-Fi issue, but when I start troubleshooting, I go, well, that person has an IP address on a subnet that doesn't have access to this resource because that's a visitor SSID, which has no access to internal resources, that kind of thing.
I love how you said that you can everybody has Wi-Fi at home pretty much. And you can just have a lab and learn that way. There's some free, I don't know if I'm using the right terms, but like heat map software out there, right? I've always wanted to do this and haven't, but I want to walk around with my laptop and look at the visual representation of my Wi-Fi. Is that what a heat map is? You can see your Wi-Fi?
If it can display signal strength on a floor plan, that is a form of creating a heat map from that device's perspective, which is pretty good.
Do you have any free software you recommend? Or just Google it. Like what could I put on my Mac and just walk around my house and see Wi-Fi? Like if I wanted to.
Yeah, I can tell you some of the applications I use on a daily. I don't know any free heat mapping software.
Oh, okay. You use all the.
I know there's some that are out there. I just don't remember the name. And there are some that are inexpensive compared to some other software. But on a Mac, I use Wi-Fi Explorer a lot. There's also on a Mac tool called AirTool and Wi-Fi Signal, all by the same guy. I think his company is called Intuitive Bits. If you just Google those names, you'll find it. On Windows, I'm not so sure what's there now. I've tried to find reliable software, but they tend to either come or go, or they don't work right. But I know there are some PowerShell commands that you could run to give you some statistics over your Wi-Fi network, like your signal strength and which AP you're connected to, which would indicate by the term BSSID what your signal strength is. Then there are different. Wireshark I use that. And so if you can capture, same as you can do a PCAP on the wired network, you can do the same on a Wi-Fi network. Capture frames that fly through the air. You can capture those.
Whoa.
And really understand how Wi-Fi is, how an AP and a client communicate.
I could see Wi-Fi, Tim.
You're like a spy now, Andy.
I am a spy. You got anything else, Tim? I've learned a lot here. I don't think my brain can handle anything else.
This has been great.
There's a lot to dive into.
Yeah, there is. Yeah. Yeah, I think that probably means we need to wait less than 110 episodes before we do another one on wireless. But yeah, we'll see. But Rowell, thank you so much for joining us. Where can people find you out on the socials?
Yeah, you can find me on Twitter at Rowell Dionicio. I tweet a lot, or you can find me on LinkedIn. You can also find me and my co-host Francois on the Clear to Send podcast, just cleartosend.net, where it's strictly Wi-Fi. So we actually tell people if they want wired network engineering stuff to go to like your podcast to go listen to that.
We appreciate that. How long have you been running that now?
Oh, since 2015.
Oh, wow. That's impressive.
You still like it?
I didn't think we'd come.
You still enjoy it?
Sometimes it's like a job where I don't know if I can come into work today.
Isn't it amazing how much you go through, right? Like you're just, running the show and topics and research and just a lot.
That's the hard part. Yeah. It's become the research into coming up with the content has been a challenge. Like I have a topic in the hopper for a long time now, for a few weeks. I just haven't had the time to lab it up, and it's strictly about. It kind of dives into Wired a bit, but it's about iOS device discovering an Apple TV and how it can discover it, even though the Apple TV is not on a Wi-Fi network, but it's on a wired network and on a different subnet. And so I have I have a lab I'm setting up specifically with my iPhone, my Apple TV, and a Palo Alto firewall in the middle with one access point too.
Damn, you got a Palo at home?
I do.
Big money.
Yeah, that was without
NFR,
without getting too deep into it. Yeah, that's definitely something I've come across too. Is you run into some of these technologies like AirPlay that leverages multicast DNS. That's not. I mean, it was designed for home networks, right? So it's not a routed protocol. Enterprise. And then you have everybody who wants to bring these into production environments, and it's like we're much more segmented. We do this for usability and security, and no, I can't easily bridge those two networks together, and it just becomes a whole thing.
I didn't say my favorite phrase yet. It's it works at home. Why doesn't it work at the office? And I'm like, wait. It works at home. Do you have like 10,000 clients and 9,000 APs?
I don't have an IT staff at home, but I can get this to work. Why can't I do it here?
Yeah, I hear that a lot too, and it annoys me.
Yeah, I'm looking forward to that. You'll have to let us know when you release that one. That's interesting. But thanks again. I like Palo Altos, so. Thanks again for joining us, Rowell. Andy, always a pleasure, my friend.
Tim,
keep the scruff going.
Rowell, pleasure meeting you.
I don't care what your wife says.
Nice to meet you too.
You know what? The only reason I have it is she digs it. I'm just trying to keep it going over here, Tim. You know what I mean?
The only reason I have mine is because mine doesn't like it. I'm very spiteful, if you didn't know that about me.
I can't really grow it, so.
Well, I can't either. Mine's trashy as hell, but I've embraced it. It's my thing now. I'm slowly trying to become the creepiest looking dude on the planet, and I think I'm doing a good job.
You know what? You got to stop with that. You look really good.
Thanks, man.
I like what you got going on.
Yeah, you both look good. I don't know what you guys are doing.
I wanted to say it earlier. Rowell has the most soothing voice. I feel like I'm so zen, but right? Like he's like, hey man, what's going on? He's got the
welcome to network engineering sheets.
Oh God, Tim, we better end it before it gets weirder.
Thanks everybody for joining. To find out more about us, you can check us out on our website, artofnetworkengineering.com. Find us on Twitter at artofneteng, and Google us. We're anywhere and everywhere. We tweet as a podcast, as us as individuals. So you'll find us out there. Thank you for joining us on the Art of Network Engineering. We'll see you next time.
Hey y'all, this is Lexi. If you vibe with what you heard us talking about today, we'd love for you to subscribe to our podcast in your favorite podcatcher. Also, go ahead and hit that bell icon to make sure you're notified of all our future episodes right when they come out. If you want to hear what we're talking about when we're not on the podcast, you can totally follow us on Twitter and Instagram at Art of NetEng. That's Art of NETENG. You can also find a bunch more info about us and the podcast at artofnetworkengineering.com. Thanks for listening.